All right, 2.1 is kind of a neat problem. It says there are infinitely many parabolas of the form y equals ax squared plus bx plus c that go through these 2 points. Find them all. Okay, first up, why am I saying parabolas of this form? It's because this is going to find all the parabolas that open upward or downward and go through those 2 points. There are other parabolas that are sideways, and we're not going to find those. And they're not easy to define, but slanted parabolas. We're not going to find those. But as far as all the ones that open upward or downward, we can find all the parabolas that goes through these 2 points. And we do that the same way that we did the other problems. The only difference is we've only got 2 equations. So this point here is going to give us the equation. Let's see, I'm going to plug into ax squared plus bx plus c equals y. So plugging in the 1 is going to give me a plus b plus c equals 3. Plugging in the 4 is going to give me 16a plus 4b plus c equals 1. So this is the system I've got to solve. Let's stick that into Octave and get the answer. All right, so my matrix in this case is 1, 1, 1, 3, and 16, 4, 1, 1. Now, the thing is, we're definitely going to get a free variable here. When we row reduce this, let's see, it turns into that. I'm going to copy this because I want to make some notes on it. 1, 0, minus a fourth, minus 11 over 12. Then below it, we've got 0, 1, 5 fourths, 47 over 12. Not the nicest numbers in the world, but nothing wrong with them. All right, so remember what this means. We've got a leading one here and here, but this over here is a free variable. Remember, this is A, this is B, and this is C. So I've got to write the solution out as a parametric solution. This top equation gives me this top equation, I can rewrite it as A equals negative 11 over 12. And then I'm going to move this to the other side, so I get plus 1/4 C. And B, the second line is going to give me B equals 47 over 12 minus 5/4 C. And so the parabola that's going to work for us is going to be, I'm just going to leave it written like this. Actually, I'm going to add one thing. I'm going to add C equals C on the bottom. So I'm just going to leave my solution written like that. And that's going to tell us what we, that gives us all the parabolas that go through those 2 points. So let's look at Desmos and draw those. All right, I want to go, let's see. I'm going to just pull up Desmos and refer back to the work I have here. What we have is y equals ax squared plus bx plus c. And it's asking, do I want to add a slider? Now, I don't want to add a slider for anything but c, because a and b are going to be, we're going to get those from the formulas for a and b. So let's add a slider for c. And then down here, I've got to tell it a is equal to negative 11 over 12 plus 1/4 c. And b is equal to 47 over 12 minus 5 over 4c. All right, so notice that gives us a parabola there, and we can move it around. But what are those 2 points that we were supposed to have? The 2 points were, so this is everything that goes through 1, 3, and 4, 1. So let's graph those on here, 1, 3, and 4, 1. All right, so we've got those 2 points there. And if I take this C and start letting it move around, this gives us all the parabolas that go through those 2 points. So I think this is kind of a neat thing to see because you can animate it and see it here on Desmos. But this gives us all the parabolas that either open upward or downward that go through those 2 points. And notice right here when it switches from opening downward to opening upward, there is a value in here that would make it be a straight line. It would be whatever the value is that makes A 0. So if you wanted to, you could solve this out for A. You can figure out there is one sort of degenerate place in here where instead of a parabola, it's just the line that goes through those 2 points. So anyway, that's how we do that problem.